Hypothalamus artificial intelligence presents information related to the optimization of energy efficiency in brewing industries. Optimizing energy efficiency is a complementary process to optimizing production, which must be done if you want to maximize the return on investment of a large industry. Demand response and industrial energy efficiency. Some time ago, electricity was produced by generation plants, sent through high-voltage transmission lines to substations, and then distributed to consumers, who behaved passively. In a regulated environment, generation, transmission and distribution are operated by a vertically integrated enterprise, usually a state enterprise that has a monopoly for the supply of electricity, whereas, in a deregulated environment, different parts of the electricity grid are owned by different companies, mostly private, and the electricity markets provide a platform that encourages competition and active consumers. Due to the new power technologies, this liberation of the electricity market has reached the industrial factories that must face this new opportunity. To achieve energy efficiency, industries must include in their digital transformation processes the management of energy, and the control of the carbon footprint. This involves two major processes related to advanced analytics. Offline optimization, planning. This stage is related to the optimization processes that must be carried out prior to the commissioning of the redesigned energy system in accordance with modern methodologies of advanced analytics, and available computational power. Part of this stage are the following activities. Redesign the power supply system in accordance with the new power technologies in force and with a vision of the near future, due to the speed of change of such technologies. Presumably when the industrial plant was built, new concepts, such as smart grids, did not exist. Optimize the industrial process using complex modern mathematical models. It is possible that the industrial plant is operating based on outdated mathematical models, which do not take into account the computing power of the current methodologies of advanced, parallel and distributed analytics. Integrating the planning and programming of industrial processes, transformation of matter, with industrial services, transformation of energy, this is a core element in the whole process. The diagram presents what could be an old power supply system. A modern power supply system is impacted by new power technologies and advanced analytics, artificial intelligence, machine learning and large-scale mathematical programming. The second major digital transformation process is related to online optimization, programming. The final part of the process of restructuring an energy system is the so-called demand response, which involves the participation of consumers in energy systems, as a means of optimizing their profits. At this stage you should use an optimization model for the planning and scheduling of the dispatch of the energy system, together with the optimization of production. Use models oriented to the optimal control in real time of the dispatch of the energy system. Energy trading and risk management. This activity is commonly called ETRM. Optimizing the beer industry's tactics involves integrated modeling of the breweries and, in many cases, soft drink supply chain. The supply chain integrates multiple production plants, which must be modeled individually, each with its own peculiarities. The current computational power allows to model in great detail each of the production plants, the breweries, the packers and the distribution centers. This allows to visualize all the existing bottlenecks, and that affect the maximization of economic gains. Hypothalamus AI considers the production process as a union of two processes. Product transformation, conversion of barley into commercial products, through processing units, and energy transformation, processing of auxiliary industrial services required by process units, and which are consumers, or energy producers, in the service units. To optimize energy efficiency, the first step is to optimize the integrated supply chain, since this is the part of the production process that consumes more economic resources. High beer is a mathematical model of high complexity, generic at the aggregate level for the beer sector. High beer optimizes beer production throughout all the facilities that make up the supply chain. The level of aggregation is related to the detail of modeling processes in the process units, such as breweries and packing lines. The goal of optimization is to determine the production plan that minimizes production costs, or maximizes economic utility, and meets the demand for finished products, beer and soft drinks, during the planning period. The second step in optimizing energy efficiency is the integration of the industrial process plant with the industrial services plant. The optimization of industrial services corresponds to a mathematical model oriented to the optimization of energy consumption in industrial plants that include large-scale industrial service plants, such as refineries, petrochemicals, and in general manufacturing industrial plants. These services often include self-generation, cogeneration, and the exchange of electrical energy with the interconnected electricity transmission system. The goal of the model is to minimize the consumption, or cost, of energy required by industrial processes. The industrial services system is combined with the production process model to holistically optimize the transformation of raw materials into finished products. The high beer ISO model can be integrated with the high beer industrial production model, or it can be coordinated. Integration involves a single optimization model. Coordination involves two stages: production optimization using high beer, and optimization of energy consumption using high beer ISO model, having as a border condition the results of high beer. The increase in volatility in electricity prices, together with new opportunities for demand management and the possibility of satisfying energy consumption with several electricity, gas and other energy contracts, must be complemented by optimal operation in industrial processes with high energy consumption. There are different sources of electricity supply, which are characterized by connectivity with the different entities of the system and by the form of contracting that exist for them. Interconnected system power, power purchase agreement, PPA, power supply contracts, BOM-type contracts, build, operate, maintenance and transfer, equipment rental contracts, own generation, and industrial processes that generate energy. Once the best option is decided, the energy exchanges that will be carried out to coordinate all the sources must be planned and scheduled. The interested reader can request, from Hypothalamus Artificial Intelligence, information related to use cases which integrate the planning of production operations with energy management. Thank you very much for your attention.